All right. So, welcome to our next lesson, which is expected value. And this is our unit of probability and statistics. So, expected value is basically what do you expect to happen, whether it's in a game or in a situation. So, it might seem like expected value is very difficult, especially when you look at the formula booklet. So, the formula booklet has this in it. It has expected value is going to be this symbol, which is sigma, which means add up, x times the probability of x being x. Okay, that's how you would say this. But basically, in English terms, basically you're going to do is you're going to add up all the values, which is the x times the probability of that x happening. Okay, so again, it looks like it's very complicated, but it's really not when we do it. Pro tip that you need to know is for a game to be fair, expect the expected value has to be 0. And another pro tip is all the probabilities in the distribution should add up to 1, right? So the probability of the total distributions happening is going to equal 100%. All right. So here's an example. I told you again, it looks complicated, but it's really not. So a person rolls a 6-sided die and wins the number of dollars shown on the face. So for example, if they roll a 6, they get $6. If they roll a 3, then they get $3, so on and so forth. What is the expected amount of money won in a roll? Okay. So to do this, let's go ahead and stay organized. So we have our x and we have our probability of that x happening. So x equals x. You could just write probability of x. And when you have a die or a dice, you can either roll a 1, 2, 3, 4, 5, or a 6. Okay. Don't know why I left it like that. Okay, cool. So what is your chance of rolling a 1 on dice, right? So that is going to be 1/6. Probability of rolling a 2 is another 1/6, so on and so forth, right? So this is a 6, 1 over 6, 1 over 6. All right. So now they're asking us the expected amount of money that's won in a roll. So let's go ahead and write down our formula. The E of x is equal to, and just watch, right? We're going to do x times the probability of x happening. Okay, so let's go ahead and do that. 1, right? Here's our 1 times 1 can happen 1/6, right? Plus 2 times 1/6 plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6, right? And you can roll a 6, and that's a 1/6 chance of that happening, okay? So 1 times 1/6 is 1/6 plus 2/6 plus 3/6 plus 4/6. Now you could take all of this, just plug it into a calculator. But I want to make sure that you understand where this is coming from, plus 6 out of 6, okay? So now when you add all this up, you're going to get 21 over 6, which is the same thing as 7 over 2. 7 divided by 2 is 3.5. Since this is money, this is $3.50. So what is the expected amount of money won in a roll? And we can say you can expect to win $3.50 per game. All right, in a roll. Per roll, I should say. All right, so let's see what happens, right? So if it costs $4 to play the game, right, and you can expect to win $3.50, then is it worth it? The answer is no. It's definitely not worth it, right? And why? Because it costs more to play, right? $4 is more than $3.50. It costs more to play than it is to actually win the game, right? This is your chance of winning is $3.50. So $4 is more than $3.50. So it is not worth it to play the game. Okay. Hopefully you have a better idea of what expected is.